distinguished guest. To begin today's session, I would like to invite our first expert, Mr. Mridul Garg sir, and the topic of his session would be moving from machine learning to deep learning. Mridul Garg sir is a seasoned data scientist with more than 10 years of experience across fintech, BFSI, manufacturing, and government sectors. He specializes in predictive modeling, data processing, and machine learning with technical proficiency in Python, R, SAS, SQL, and cloud platforms like AWS and Azure. He has led impactful projects including customer segmentation, insurance propensity modeling, smart manufacturing optimization, and credit risk model validation. With a strong foundation, he did his MTech from IIT Bombay. He has led data science project at Paytm, Deloitte, PGP, PGP Glass, and HSBC, delivering impactful business solutions. He also served as the research associate with the Ministry of Rural Development, where he helped digitize and optimize the monitoring of large scale public welfare programs, contributing to improved data quality and program efficiency across 28 states. He is a recipient of the Young Achievers Award at PGB class and was among the top 2% in GATE entrance examination. He was also selected for UNDP Backend Unleash Innovation Lab in Denmark, reflecting his global exposure and commitment to sustainable development and innovation. Sir, I would like to invite you, Mr. Mridul Garg, sir, for your next technical session.
Yeah, thank you, Archita, ma'am, for the kind words and the very detailed introduction of me. Let me switch on my video and let me know if you can see me. Can guys see my screen?
Yes, yes.
Okay. Yeah.
Visible.
Okay. Cool. So good morning, good afternoon, good evening, one and all. So thank you for joining today's session uh, with the title Moving from Machine Learning to Deep Learning. And I'm honored to have between very distinguished group of educator, industries, veterans, and the students here. So in next 1.5 hours, we will discuss that how the revolution from machine learning to deep learning has been happened in the industry, given the huge large data set size and all the new technologies coming in. So if I talk about the content of my presentation, so what we'll explore together is, so first we will spend some time understanding the evaluation from traditional ML to deep learning. We will also discuss that how what is traditional ML, just to be ensure that we are on the same ground. And we will have some polling questions as well to keep the session interactive. Then we will also discuss that what are the limitations of the traditional ML then and why deep learning exists and what are the different use cases of deep learning. Then we'll also spend some time discussing that what is deep learning, what are neural networks, and we'll spend some time discussing that why there is a need of deep learning over traditional ML and what are the different technologies and the industry segments which you are working on the deep learning sides. Then we'll spend some time on understanding what are the key differences between traditional ML and deep learning, and depending on the industry, depending on the projects, depending on the use case, how to choose and when to choose traditional ML, when to choose deep learning. So we'll also discuss some of those aspects as well. Then we'll also talk about some real world applications which have transformed the industries, BFSI industries, manufacturing industries, credit risk industries, which are using the ensemble framework, where they have both traditional ML and the deep learning on the basis of the use cases those are interested in. Then we'll discuss what are the practical implementation and strategies, and we will also discuss the common challenges while using the deep learning and what are the different strategies, small strategies which we will follow so that we can solve those challenges in the deep learning. So going forward, so we'll first start that what is the traditional machine learning. So, uh, Mr. Manoj, can you please start
Yes.
the poll one? Yep,
Yeah,
so
yeah.
that we can have
Sumit
idea
sir,
that how many of
execute
the
the
audience.
first poll.
Yep, first poll. Yep, yep.
Yeah.
So
Dear
I have
part
the polling question in my screen. So if you can launch the poll, Mr. Manoj, so that we can have the answer set. So basically, the idea is to understand, amongst the audience, how many have the
Yes, yes.
knowledge of traditional ML, so that
Uh,
which will help our session as well. Yeah.
okay. Sumit
So
sir, Sumit sir,
Sir,
yeah, execute the poll. Yeah, participants.
कर दिया मैंने क्विज.
Okay, okay, thank you. Participants, you can see one question in the form of poll, and you need to answer.
So basically, the idea is to just have a sense check that amongst the audience, how many of have the traditional machine learning language. So it will help me to decide how much depth I need to go, for this particular topic. Yeah. So let's give it 2 minutes. So I think 2% of the participants have responded.
Participants, please reply fast. I am requesting all participants to participate in poll.
Surprisingly, I am also seeing the answer for no and not planning to. So I highly recommend those participants. The topic of this workshop is machine learning and IoT, and so please do plan to learn traditional machine learning if you are not planning so. Let's give it last 45 seconds. Only one third of participants have responded till now.
Yeah.
We will resume when we reach at least 50% of the participation. And one small clarification, this is just for the first question, So we'll have the poll for question 2 and 3 later on in the middle of the session. But this poll was specifically for question 1. Okay, I think let's get going. So we have around 42% of the participants, 62 participants have responded.
Yeah.
And I see the results are, the 21% and the 42, so more than 50% of the audience have the basic foundation knowledge of the traditional ML. So we'll just touch base those concepts, will not go in that deep. So having said that, let's begin. Yeah. So let's begin at the foundation, the traditional machine learning. So
Okay.
many of you are already familiar with these concepts.
Mridul sir, should we close the window of poll, I think?
Yes. I think I've already ended it, Manoj sir. So we'll again launch it for question 2 in the middle of the presentation.
Okay.
After 20 minutes. Yeah.
Okay, fine.
Cool. So I think as the survey results says that more than 50% of the basic foundation. So many of you are already familiar with these concepts, but it's important to establish our common ground. So the traditional machine learning emerged from statistical learning theory. And from last couple of years, it has been the backbone of the data-driven decision making. So at its core, it relies heavily on feature engineering, the art and science of selecting and transforming the raw data into the meaningful features that algorithm can work with effectively. So at the screen, you can see a traditional ML pipeline. So how conventional ML pipeline workflow works. So we have a data extraction and analysis. So now the data extraction could be from multiple sources. So it could be a CSV data source. It could be a database, a SQL table from which we are extracting the data using, let's say, Snowflake or data lake or anything. It could be some unstructured data as well, like the images, which we convert the images into the RGB codes using, and we digitize those images and extract the the RGB codes from the images. It could be from some videos as well. So there could be multiple types of data sources, and depending on the use cases, we extract the data and we do some basic EDA, the exploratory data analysis, to have a sense. Now, at this junction in this flow, it's also very important to have the business understanding aspects as well. So let's say if we talk about a use case in a in a financial services industry, let's say to build a predictive model for which let's say if you apply for a loan, then just to devise that methodology, which customers will have what interest rate and for which customers we will approve the loan or not. So the input features could be like the age of the customer. The input features could be like the where the customer is located. The customer is in tier 1 city, tier 2 city, tier 3 city. What are the educational backgrounds of the of the applicant? What is the income range of the applicant? So there will be some parameters related to the customer profile as well, and the banking relations as well. So let's say if you're going to HDFC Bank and applying for a personal loan, so and if you already have a personal, and if you already have a saving account or a current account or a term deposit account, let's say in the HDFC Bank, then the bank might have your previous transaction history. If you availed your personal loan in the past, then what were the transaction details like? Were there any instances where you have defaulted? If you have defaulted, for how many months you have defaulted? What is your credit score? So on the basis of all these three things, we will prepare the initial data for the model. Then on the basis of this data, we'll also create some features. So let's say, just to give an example of the feature, so we might create some feature like on the basis of the age of the customer, on the basis of the demography of the customer, and all other features as well. And let's say if I talk about the transaction related data, then some features like, from how many days, since last many days, you have interacted with the banks or not. So on the basis of all this, you have your input data, you feed it to model, and you also have some features created as well. Now here, a major point is very important, where which says that you should have the business understanding as well. So if you don't have the business understanding and you just simply have the data, you do EDA, and but if you don't have that particular business knowledge, then you might not be able to create the very useful features, which will help model to learn the business sense which you are trying to have. So it's quite important to have the business sense, the domain knowledge, the domain expertise. And after having this model data, after having these features created, you do some model training. So let's say the example which you're talking about was related to the a classification problem, where the target variable was whether you will approve the loan or not. So it could be only yes or no. So it's a simple binary classification problem. So you will use a classification model here. Now there are multiple steps of classification models. Just to start with the statistical analysis, you can use first the logistic regression, where you will see what's the Gini coefficients, how the ROC AUC curve is looking like, and on the basis of that you will decide a threshold and will go ahead about the classifying yes or no. If I talk about the higher analytics model, then you have the random forest classifier as well. You have the support vector machines as well. Then after you have trained the model, then you will evaluate the model on the basis of the model metrics. So can I have some answers from the audience, and that what are some basic model evaluation metrics or the criteria for a classification model? Can anyone just name one or two model metric which we use in the logistic regression?
Participant, you can answer in chat box, please.
Yeah. I highly encourage the participation from the audience. Yeah, yeah. Recall is a good metric. Yeah. CNN is a uh, algorithm. It's not the metric. Karthikeya, can you please elaborate what do you mean by CNN? That's F score. That's very good metric. Yep. Good. Some more accuracy, recall, F score, Manshu sir. Yep. The precision is also a very good metric. Yep. Awesome. So these are some wonderful answers. So again, uh, when to decide recall, when to decide precision, when to decide F1 score, it totally depends on the business case which you are using. So let's assume a scenario where where you are trying to build a model to predict whether the patient has a cancer or not on the basis of his medical reports. Now here, if there are certain cases where the model is having the false negatives or the false positive for the patients, for which the cancer is there, but it's saying the cancer is not there, then it can have a very significant impact on the livelihood and the life of the patients. So it totally depends on the business case, that on which particular model metric you're interested in. So like for the propensity models, we generally use F1 score for uh, and for some projects in the credit risk modelings and the derivative pricing, we also use the F1 score and the recall and precision as well. Yeah. And F1 score is nothing but it's the harmonic mean of the recall and precision. So when you select F1 score, then the recall and precisions are already being taken care of. Yeah. So now again, then you have this model evaluation criteria. Then you just train your model. Then you decide that what is your model evaluation criteria. Then you validate your model for the test data sets. So when you train the model, you don't train it on the whole data sets. You have a trend test split on the basis of what quantum of data you have. But in the generally industry practice, we recommend, the 70%, 30% split for the test and train, So once you have this test and the training data set, then you do some validation on the unseen data, which the model not have seen yet. So you also keep some data for the out of time validation as well. Then you evaluate and validate your model on that data. Then you finally have your model. Now, it's not a simple process that I've just explained in 5-10 minutes. So it have the multiple iterations as well. So let's say if you first train the logistic regression model, it might be the case, in the out of time data or the unseen data, the model is not performing well. The you might have some true negative, you some have the false positive or the false negative cases. So it's very important to do some this iterative process, this logistic regression, or it's a random forest, or it's so it's all about the iterative process and the learning from the last mistakes, in the data science fields. So sometimes the logistic regression model also works very well, and sometimes the random forest classifier also does not. Right. So it totally depends on the data, that how much features you are able to figure out, and it totally depends on the business understanding case, that how much business understanding do you have. Yeah. Now again, there are some complications and some regulatory concerns. So if I talk about the tree based models like decision tree, or let's say the XGBoost, or any higher ending models which does not have the explanatory feature, but in the regulatory perspective, let's say if you are a bank or a regulatory body, then the regulators, like in India we have RBI, in US we have US Fed, in in South Africa you have first and regulatory bank. So they are highly interested in the model explainability part of it. So let's say if you're making some predictions, then on the what basis the model has made those predictions, what are the relation between the input and what are the coefficients. So there are some regulatory concerns where the regulator are highly interested in the mathematical, or the relation between the input parameter while arriving at the output. So this mostly majority of the traditional machine learning models are very good on the model explainability point of view. That we and for the linear and the logistic regression, you can directly have the mathematical equation. So if I talk about the linear regression, then you can so basically we are plotting a straight line on some points. So you can directly have the coefficients value, the intercept value, and you can very easily interpret, that how why this is the prediction. Having said that, let's now think about some algorithm like linear regression for predicting the continuous value, decision trees for classification problem, support vector machine for finding optimal boundaries between the classes. Now, these methods require us to understand our data deeply and manually craft the feature that will lead to the good performance. Now, the beauty of traditional ML lies in its interpretability. We have already discussed this. So when a decision tree makes a prediction, we can trace exactly why it made that choice. So if you are familiar with the decision tree, then you will have the root node, on the basis of root node, on the basis of some rule-based logic, So let's say if the age is greater than 50, or if the age is less than 50, then you will have this two splits in the branch. Then you will have some other rules behind it as well. So the beauty of traditional ML lies in its interpretability. So when a decision tree makes a prediction, we can trace exactly why it made that choice. And when a linear regression model gives us coefficients, we can understand very precisely that how each feature contribute to the outcome. So this transparency is very crucial in many engineering applications, in manufacturing as well, where you have some use case like. So now let's again think of a use case where the final objective is to determine that what should be the optimal temperature range for a particular machine to have a minimum defects at the output. Now, if you simply go to the shop floor people and say, this is my advanced machine learning model, or they'll say it's my advanced deep learning model, but you can't explain them that why the reduction in temperature is contributing to the reduction of defects. They won't agree. So they will have that resistance because they are very traditional people, and they are working on the shop floors from last 20-30 years, and they have that experience. So I have personally experienced this types of challenges while interacting with the traditional folks who are very new to data science. So here comes, so if you are able to give them a mathematical equation, and if you can explain them mechanically or thermodynamically, boss, this is the reason. If you will decrease the temperature by, let's say, 2% or 3% there, and you will increase the pressure by X%, then you will have a reduction in defects, and you will uh, achieve your business objective. So that the traditional machine learning have that beauty where you can easily interpret that how the model performance is, what is the model outcome, and all these things. And traditional ML works exceptionally well with the structured data. When you have a CSV data, let's say the comma separator file, or a tab separated file as well, where you have the data in particular rows and column page. But the deep learning will have more accuracy or very good performance over the unstructured data as well. And we will have the detailed discussion for those in the upcoming slides as well. Yeah. So the traditional ML works exceptionally well with the structured data, the 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 kind we find in databases, spreadsheet, and the sensor readings as well. So it's computationally efficient and can work with smaller data sets and provide results that we can validate again against our domain knowledge. So there would be multiple instances, where if you have the business sense. So let's say if you don't have a business sense, and if you have made a model, and you will go. So let's say you have created that model and you are discussing that model to a business person, let's say a business analyst or a business translator working in a manufacturing industries. If you closely work with the traditional ML, then that business understanding will develop automatically, and you will feel very confident while interacting with that business expert or the business process owner, because you will have that interpretability that why the model has met that prediction. But if you have a very large amount of data, let's say the millions of rows, or a trillions of rows, and you will have some unstructured data as well, then sometimes computational efficiency also are the major roadblock, using this the traditional machine learning models. So as the data become more complex, like images, audio, natural language, that the traditional begin show its limitations. So the manual feature engineering that once is its strength, become its biggest bottleneck. Now if the data size is very huge, you will have a lot of unstructured data. Then you can't have the feature engineering by your own, because that data is unstructured. You will not able to link that data with the business understanding and all those things. Yeah. So any question till now? Now we'll shift to that, what is deep learning and why there is a. I think we have developed that understanding where we know that, that what are the basic limitation of traditional machine learning, and why we move from traditional to deep learning, and what are the strength of traditional machine learning. Any question? Anyone?
There are no questions are in chat box. Participant, you can raise your question in chat box, please.
Cool. Or else we can have the question at the last as well. So we'll have 10 minutes last.
Okay, sure.
Yeah. But if anyone have any doubt in the middle of the session, you just raise your hand, or you can just in the question on the chat box, and we can have the discussion directly at that junction as well. Good. Now, so I think as we have already discussed this, that what are the limitation, that spark that innovation, and why the deep learning or this neural network, or the convolution neural network, RNN, and all this stuff I talk about. Then, and how is this journey become? So the key limitation of the traditional machine learnings are, in the traditional machine learning, having said and I already said that the business understanding is a very crucial thing. So you should have that expertise to understand the business very closely. And if you have that understanding, then you will be able to think of those features, which have the impact on the business, and which will have the impact on your business case or the model. So the feature engineering is the first bottleneck that requires expertise. And the traditional ML has seen the poor performance on the high dimensional data as well. So what is high dimensional data? So the high dimensional data is, the data is very big size, where you have the millions of columns, millions of rows, and so which you can't think of. And it also has the limited hierarchical representation learning. So as the data size grows, then the learning of in the traditional ML setup is quite limited. And it struggles with the images, audio, NLP, all types of this unstructured data, and all these things. So in my screen, you can see a graph, where the graph is basically the model performance, of the traditional ML and the deep learning. So on the y-axis, you have the performance percentage, and in the x-axis you have what is the training data size. So you can see this, as the training data size increases, the model performance of the of the deep learning is quite higher than the traditional ML. But you lose the model explainability part here. So if you go to the deep learning, so the here the neural network are so complex, there are so many deep layers, so you lack the interpolative point of view. So if you go in research and you will see, in the mostly in the BFSI industry, or let's say any regulated industry, the experts mostly prefer the traditional ML over deep learning because the regulator needs why you need so much uh, economic capital, why you need so much repo rate, why you need so much this. So all the economic models or all these things, the time series forecasting, your linear regression, the logistical regression have a great amount of explainability. So mostly this traditional ML is being used in the regulatory setting like BFSI or defense as well. Yeah. Now, let me share a story that many of you might relate to. So let's say, imagine you are working on a computer vision project to detect defects in manufacturing parts. I don't know if there are some audience from the manufacturing industries or some professors or some educator in the mechanical domain. Uh, they will highly relate it. And so let's say if your main goal to detect the defects in the manufacturing parts using the images, the computer vision images. So let's assume in the production line, in the output line, you have installed one CCTV camera, which is just capturing the millions of photo for all the products which are being produced. And your main goal is to detect, so you basically you want to automate that process. You don't want a man to stand there and select who are the defected and which are not defected. So basically, you want the technology to help you here, and you want to build that model which will detect the defects in the manufacturing part. So let's say with the traditional ML, you will need to manually identify relevant features. Like, so let's say if I uh, just talk about an example of let's say a glass bottle, the glass bottle could be of a beverage or could be of anything, So in the traditional ML, you have to think of its feature like, what is the dimension of the bottle, what is the age gradient, what are the texture pattern, what are the color distribution. So let's say in the glass industry, a small crack can lead to a defective product. If the age is not proper. So let's say if we're talking about the pharmaceutical bottle, so let's say a glass bottle which is used to just pack the cough syrup. So if you have a crack on the upper side, or let's say some crack on the lower side, so if that product is going to a pharmaceutical industry and to the end goal, then you will have a regulatory concern as well. So that product should not be passed if you are using this computer vision model. So if you think of a traditional ML setup, then you will have to think of all these features manually, like edge patterns, texture pattern, the color distribution, and you will first need to have or collect the millions of images, and you will also need to have the quite a good distribution of images where you will have these types of defects. So you must have some images which have the edge, the cracks in edges. You must have some numbers of images which have the cracks at the bottom. You must have the images where, let's say, the diameter or the upper circumference or the upper radius is quite varying for the similar type of SKU. So you will spend weeks or months, engineering these features, often requiring deep domain expertise. So even after all this works, your model might struggle with variation in lights, angle, or new types of defects it has not seen before. So let's say now you have placed a camera, and in the morning the light intensity is different. In the evening, the light intensity is different. So here, having said that, you have completed all these things, you will again have these limitations where by just changing the setting, like a small variation in the CCTV camera position, just a 1 mm, your whole image, the features can be biased. They could be wrong. So this is the feature engineering bottleneck, that has blocked the traditional ML when dealing in the complex and the high dimensional data. So what is high dimensional data? Basically, we already discussed this, like this images. So let's say in your phone, you just click a photo. Let's say the size is 1 MB. So 1 MB is a quite good data of data, and at the backend, this data is basically stored in the form of 1 or 0 only. So when you have this high dimensional data, then you will have this complexity where the feature engineering could be bottleneck. if you want to have a data science use cases. So this challenges is extended beyond computer vision. So in NLP as well, the natural language processing, capturing the nuances of human language through manual features prove nearly impossible. So let's say we all use English, when we chat, and if you want to create an NLP model, so there could be a lot of variation. Like, let's say if I'm saying kahan ja raha hai tu, so most so let's say I use KHA for kaha. Many of you use KAHA kaha. So there could be multiple variation like this, when you NLP. And thinking of all this millions of circumstances, this millions of possibility of just having a single word for the sense or the emotions which I'm trying to say. So it's very highly nearly impossible in the traditional MS setup to think of those millions and millions of features. So how do you manually encode context, the sentiment, sarcasm, and the cultural references? So the traditional ML also hit scalability walls. So while adding more data sometimes helps, there were often a performance plateau, which you can see in this graphs as well. So as the data size increases, the performance also degrades. Just give me a minute. Hey, apologies everyone. My little daughter just bombed in my room. Yep. So I think we were talking about this performance issue with the when the training size of the data get increases too. So while adding more data sometimes helps. Yeah, again, there is again one other philosophy having the large data. So in the traditional ML setups, so if you have more data, then it's also said that your the model performance also increases because now model have learned a lot of things with the good and vast amount of data. But there is a limitation. Again, if you have a very, very huge amount of data, then the model performance can degrade because feature engineering here can become bottleneck. So while adding more data sometimes helps, but there are some performance issues as well. There could be some cases where the model does not automatically discover more sophisticated pattern, no matter how much data we show through the model. So these limitations are not flaws in the traditional ML. They are just, I think, they are just simple boundaries of ML, which was possible with the the algorithmic tools available at that time. But they have created a clear need for something more powerful, something that could learn features automatically and handle the complexity of real world, which is the unstructured data. So I would not say these are the limitations. So these are just boundary of the traditional ML systems. But as in this modern era where we have the large amount of computational availability, we are living in the cloud era, we are having the transformers, we are having the auto ML models, So, and the mostly this all the social media data and all this news data is the unstructured data. These are not the structured data. So as the amounts of data in the world is increasing day by day, and that to the unstructured data, so there is a clear need of something powerful that could learn features automatically and handle the complexity of real world. So let's move on. Now, having said that, we have spoken about what is the traditional ML systems, what are the limitations of the traditional email, and why we need some more advanced thing, which can learn the features automatically and can have work done. So this deep learning didn't emerge overnight. So this neural network, I think, as most of you are the professors, and I've also studied in this RGB University as well. I think in the seventh semester there was one course CNN, this neural networks. Yeah. I just felt nostalgic. Yeah. So having said that, so this deep learning didn't emerge overnight. So the neural network had been around since 1940s, but several breakthrough moments converged to make them practical and powerful. And what are these breakthroughs? the computational power which we have at this right time. So just imagine a scenario in the 1990s or the late 1990s where you have this neural network, but you don't have that computational techniques. So there were some instances in some research lab where just the training of just one single CNN model took more than a month, more than a 2 month. But as we are a data science professional, we can't wait that long. And the data science is full of experimentation. So you just can't wait for 2 months to have one result and just try another experiment. So as in the modern era, you have that computational exploratory, you have this AWS, you have Azure, you have GCP. We are living in the cloud era. So this becomes more relevant in the current era. So firstly, was the availability of the massive data sets. So this internet explosion gave us millions of images, text documents, and other types of data. And the second was the computational power, which we already discussed. Now, this GPUs, this graphical processing units, originally designed for graphics processing only, but this turns out to be a perfect for the parallel computation which uh, neural network requires. And the third was the algorithmic innovation, like the back propagation improvements, the better activation functions, and the regularization techniques. So we also talk uh, little bit about the transformers as well. The encoder decoder mechanism and some basics of LLM as well. So, but what makes this deep learning truly revolutionary is its ability to learn hierarchical representation automatically. So as we have discussed in the traditional ML setup, you have to think of the features by linking it with the business expertise or the business understanding. But here, the deep learning has the ability to learn the hierarchical representation automatically. So instead of us telling the computer what features you should look for, the deep neural networks discover them through layers of processing. Now, let me illustrate this with the computer vision. So in the first layer, a deep network might learn to detect simple edges and corners. And the second layer combines these to recognize shape and textures. So I'm again correlating the computer vision use case which we've discussed earlier. Like, so here the objective is to detect that how many defects are there in the in the finally produced product. So let's say if you're using the deep learning for that, so in the first layer, a deep network might learn to detect the simple edges and the corners, how the edges are looking like, are the edges are corner, and is any corner defective. And the second layer combines these to recognize the shape and texture. So if I say texture, the density of the glass particles. And the third layer might identify the parts of object. Like, let's say if it's a bigger product, then, let's say if it's the house, then the wheels, doors, windows, and as well. And by the final layers, it can recognize complete objects like the cars, building, or the faces. So this automatic featured learning eliminated the bottleneck that constrains traditional learning. So here we have that understanding that why the deep learning has evolved very, very significantly in today's era. Now we could tackle problem that seemed impossible before, like recognizing speech in the noisy environments, the translating language in the real time, and the generating realistic images, even playing complex game at the superhuman levels. Now there are some applications which plays chess automatically, and there are very, very brilliant than human minds as well. Now the time for the second poll. Manoj sir, can you please launch the question two?
Yes, yes, sir. So, Mr. Please launch the second poll. Participant, get ready to answer the second poll, and please be quick to answer. So, Mr. Are you? Can you hear me?
Yes, sir.
Sir, please launch the second poll. Hello. Yes, Sumit sir.
हाँ यस सर मैं कर रहा हूँ लंच
Yeah, launch the second poll.
I'll just grab my
Participants, please be ready to answer and be quick, please.
please respond fast. So these are just small steps to make the session interactive. I know it's quite late in the evening, and most of us are back from office very tired.
Be quick, participants, please fast.
The poll is only for question two. So if you have encountered any challenge while implementing a deep learning model, then what was your biggest challenge? And I think for me it was like practical implementation only. So mostly I worked in the BFSI industry, so we have not used, we have not productionized any deep learning model in the BFSI world, as per my experience is concerned. We already use the deep learning model just to have, the comparison between the champion or a challenger model, or to a baseline model that, how much performance increase you can achieve by using a deep learning model. But as this deep learning model have the limitation of the business interpretability, so we have not used them directly because it's very tough to convince the stakeholders, even if it's not a regulatory thing, that why your model is predicting this much. And sometimes there are certain use cases like where you just want to do a corrective measure over business. So let's say the business case is, what should you do to increase your sales? Now if you just say in the January your sale will be this, in February your sale will be this, but you don't that have a prescriptive analytics thing where you are going to the business and saying, boss, if you'll do this certain amount of thing or this 1, 2, 3 things, then you will have these things. So here, if you use this traditional model, then you will have those equations, dot relations, but in the deep learning you struggle. Okay, I think we can end the poll now. And the majority and more than 50% have, I think, answered that the major challenge was the mathematical complexity and the computational requirement. Yeah, but in the current era, we have, the cloud license, and also for the academia, the Azure and AWS are giving the free credentials as well, which where you can have at least uh, 50 GB machines, the virtual machines, and you can directly have the practical learnings over there. Why I'm not able to track this? Okay, cool. Now we were discussing about that what are the benefits or what are the advancement in the deep learning side. So in the image classification era, the deep learning models have now surpassed the human performance on many benchmarks. So there are multiple research, there are multiple use for this as well. And also in the natural language processing, the large language models can generate coherent text, answers question, and even can write codes. So again, this all these LLMs, the large language models, the AI, this GPT, Claude, Grok, whatever we are using. Also in the game playing vertical, also systems like AlphaGo has defeated the world champions in many games, and which were the impossible things in the 10 to 15 years ago. Now for all of us, this represent both an incredible opportunity and a significant challenge. Now we need our juniors, our students to understand this and just how to use this powerful tools, but when to use them appropriately. Now again, there are many courses, doctor, and the doctor is prescribing as a medicine. What we do, we just take a photo and just upload it to ChatGPT and say, boss, what are these medicines, what are these uses, just out of curiosity. So, but for the children specifically, for the students specifically, it's quite important to tell them when to use them, how to use them, and what to use them. Because we have seen many instances where these models hallucinate for the complex task, and we don't validate the results to the actuals, and we just use them. So it's quite important to have that sense as well. Having said that, so now as we have understood that what is the traditional ML system, what is the deep learning system, and why is the need of a why there is a need of a deep learning system. Now let's spend some time understanding the key architecture difference between both of the system. So in the screen you can see this, and we already spoken about it. A traditional machine learning architecture is, you have a input data where you have a raw features, then you do some feature engineering, and you create those features. Then you have a pre-processing where you will do some ADA, you will do some correlation analysis. And let's say if the problem is of a linear relation, then you will try to remove some multi-collinear variable. You will try to fulfill all the assumptions of the linear regressions, which is the homoscedasticity, the linear relationship between, and you will just try to have the most correlated features between input and the output. In case of the logistic regression, you will try to have a variable on the basis of the weight of gain or the information value or the Gini coefficients. So let's say if you have a multi-class, like let's say you have a variable like CT, and you have tier 1, tier 2, tier 3, T4. You will use the one-hot encoding to convert all those features into a numerical thing, and you will calculate the information value Gini, and will decide that for which variable and for what variable you want to keep your variable or not. Then, having said that, and if you have created all these features, then you will just simply train a model. It could be a linear or tree-based model or an ensemble model as well. Then you will have predictions. So in the traditional ML, you will have a shallow learning, so the single layers model with the limited abstraction. You will only have here a single layer for the learning. You require the manual feature extraction here. You have to do extensive pre-processing here. So let's say there might be a case where your data might have duplicates, your data might have a missing values, your data might have outliers. So when you do those types of exploratory data analysis, then you have to treat those outliers. So again, on the basis of business case, either you will remove that outlier, or either you will cap those outliers. Again, totally depends on the business use case. So let's say if you have data where the you have a data for different types of ages, the age of a people. Now, in a real world scenario, the age could range from 0 to, let's say, 95. Or let's say if we're considering Japan in this case, then it could be 110 as well. But in the data, let's say if you got from a bank and you have to just make a model out of it, and for this particular age column, you have the values like, let's say 120, 150, 160. And you know this, the 120, 160 can't be a true age. There might be some issue with the data. So now these are outlier in your data. So now this for this particular case, you will go to the business and will say, are this row corrupted, or only this column is corrupted? So let's say if the whole row is corrupted, then you will remove those whole row. And let's say if that particular column is corrupted, then you will again see the other columns and will try to cap those edges, on the basis of the features, other features as well. Now, once said you have this linear model created, then you will have this output as well. Now, for the traditional ML model, these models are quite simple and very easy to interpret. You can have the mathematical equation created as well. And for the tree-based model, you can have some plots like shape plots and the line plot, which does not create the direct mathematical equation, but you can have a sense, and you can have the model explainability for those types of plot. And this system, or in i5 or i7 processor, you can easily train, 1 millions of rows easily. And let's say if you're working on a cloud and you have a low storage, then the so basically this traditional ML requires very low computational requirements, and they are not very costly if I talk about the infrastructure cost as well. But they have the performance plateau. So it is said that, let's say if you have 100 rows and you have built this model, the performance could be 50%. But let's say if you have increased the rows to 10,000 or a million, that it could be the case that the model performance will reach to 85 or 90. But as you start increasing the rows from 1 million to 10 million, 1 TB, then you have that saturation point. You have that performance plateau with the traditional ML system. If I talk about the deep learning architecture, then you have the multiple hidden layer like layer one, layer two, and which we have discussed as well for that computer vision example as well. So in the layer one, the system will try to this model will try to identify the edges, corners. The model two will identify textures, and then the layer three will try to identify the different shapes as well. So they have the multiple hidden layers, very complex hierarchical representation. You don't have to do a lot of feature engineering here. They automatically have this learning things, so they learn features directly from the raw data. And all for this outlet things or the missing data thing, so let's say if you just want to do a quick and dirty things, you can just simplify all your data with no processing, and they will try to learn all these things automatically from them as well, so. And also in the traditional ML like XGBoost or the GBT, so uh, if you have to do a regression problem using a linear regression, you can't have a missing value. But you have to truth those missing values. But let's say if you are training a model on an XGBoost, which is the extremely automatically handles the null values as well. So also here in the deep learning architecture as well, you require minimal pre-processing. They have very complex black box, So as we already discussed this, they are very less transparent to the decision process. So you don't know why the output is this. So they lack explainability here, and they have very large hardware requirement. So they are completely dependent on the GPU, and you know, and when you feed them more data, then their improvement, their model accuracy, all the model metrics, and will improve a lot. So they scale very really well with the with the data volume. Now, just to summarize this key architectural difference, so the traditional machine learning follows a clear pipeline: collect data, engineer features, select an algorithm, and selecting an algorithm again a very iterative process. It takes a long. So when I talk about a simple data science project life cycle in my organization, so mostly it depends 60 to 70% of the time on cleaning and engineering the features of the data. Building a model is just the 10 or 20% of the time. Because if you are talking to different teams, so if I talk about a fintech company setup, like let's say a Paytm or PhonePe, there are multiple different departments. There is a loan department, there is an insurance department, there is a collection team. So if you are working in a data science team, then you will have to interact with uh, all these other teams which have all different workings and the product features as well. So let's say if you are talking with the collection manager, who is responsible for having a collection strategy for all the defaulted loans or the defaulted cards payments, now their way of business would be completely different. Their data would be completely different. So here the most of the time goes understanding the business, understanding the data, having the follow-up questions regarding the data. So once you receive the data, then you spend a good amount of time understanding the data, and you will have a lot of follow-up questions. Then you'll go back and ask those questions. Then you'll have a clarification. Then you'll have a final data. Sometimes there are the scenarios where the data is with the third party. There will be some data migration issues. So in a typical data science projects, 50 to 60% time is spent on the data collection, the data cleaning, and the data understanding thing. Building a model just took 10 to 20% of the time. Because once you have all the features related with the business understanding, once you have all the data cleaned, once you have all the data without null values, once you have all the data with outliers removed, you have to just do an experiment. Now in this modern era, there are certain types of tools like data IKU, where you just simply feed the data to the model, and you will just manually select all the model names as well. So you don't have to write the code for linear regression, logistic regression, all these things. There are various no code AI platforms as well, where you just simply do these things. You just pull the process data, and you will have the model comparison for the different models as well. So for the traditional machine learning, each step is distinct and often requires human expertise and intervention. But when I talk about the deep learning collapses much of this pipeline into the end-to-end learning. So the raw data goes in one end, prediction come out of the other, and the network learns everything in between: the feature extraction, representation learning, or the classification or regression, all simultaneously. So the difference is profound limitations for how we approach problems. So with the traditional ML, we need extensive domain knowledge to engineer good features. A mechanical engineer working on a vibration analysis can know which frequency pattern can indicate it bearing wear. A financial analyst understand which market indicator predicts price movement. So it totally depends on the business understanding. But deep learning can discover this pattern automatically. It needs much more data to do so. While traditional ML might work well with the hundreds or thousands of example, deep learning typically needs thousands to millions of example to achieve its full potential. And also the training process also differs significantly. The traditional ML algorithm often have closed form solutions and converts quickly through the iterative optimization. So let's say if I talk about the linear regression, then you have the gradient descent things there. And let's say if you build a random forest regression, then you use the grid search CV to optimize your hyperparameters as well. So let's say what are the hyperparameters, that what will the depth of the tree, what will the number of iteration, what will the learning rates. So you can automatically have those hyperparameter tuned for your data specifically. But the deep learning requires gradient descent through the high dimensional parameter space, and it often takes hours, days, or months to train them properly. So it totally the game of, I think, the computational thing, and and this computational power also comes with the cost. So in majority of the industry, where there are some cost limitations. So let's say if you're working on a use case where the projected saving is just a million or a billion for, let's say, a period of year, but the infrastructure cost is too high to use the deep learning model, then you will automatically have to work on the traditional ML systems if your organization or if your business can't afford the deep learning sites. So everything comes with the cost and the benefit. So it's quite crucial to understand and strategize that when to use deep learning and when to use traditional learning. So having said that, I think the hardware requirement also have varies in these two things. So the traditional ML can often run efficiently on standard CPUs, but the deep learning models, especially during training, use use GPUs or specialized hardware like TPUs as well. Yep. So time for next polling question. And also this polling questions also give me time to have a 2 minutes break as well. So Manojji, can you
Yeah.
please again
Yes, yes. Dear participants, please reply to the poll. Participants, please reply to the poll quickly. Still very few reply. Your active participation is highly appreciated. Please reply.
I see majority of the participants have responded. They use hybrid approach, combining both. Yeah, and which is the true thing as well.
Yeah.
There are any questions? No? Okay. Okay.
Majority is with hybrid approach, combining both.
Yep. I think that is a correct approach because it gives you the explainability of the traditional ML and the computation and the performance of deep learning, I think. Yeah. So now again,
Madhul
yep,
sir,
yep.
One question was there in the chat box recently. How machine learning and deep learning useful in day-to-day life?
Okay. In day-to-day life. Okay. So
Yeah.
so let me answer this. So the first is the how the ML is useful in the day-to-day life. So
Yeah.
in every setup, like whether it be a banking sector, whether it be a healthcare sector, there is a great use of traditional ML systems. So let's say and I already explained this example as well. So when you apply for a loan, instantly on any app, so how a particular app tells you that whether the loan is approved or not. It totally is on a machine learning model. So at the back end, so how it does, so how it happens is, so let's say if you're applying for a loan on a Paytm app, then it will first ask you your name, your age, your date of birth, and your PAN card. On the basis of the PAN card, it fetches your CIBIL score and all the previous loans, the relationship with your other banks, and on the basis of your features like your location, your age, and your gender, it creates a feature out of it. And while combining all these things, your credit history details, your transactional details, and your demographic details, and your personal details, there is a model for which all these features are created. These features are sent to a API through a postman or any sort of thing, and that API hits the model registry layer. And by giving all these features to the model registry layers, you will have output whether yes or no, and you see output whether the loan is approved or not. So this is a very classical and very good example that how the traditional ML is impacting our day-to-day life. Now, the talking about the second thing, then how the deep learning is useful in our day-to-day life. So all the use cases like, so let's say if you're using a Netflix, and on the basis of your last viewing history, on the basis of your preferences, the Netflix suggests you that what content which you will be interested in. The second example could be while scrolling the Instagram reels, let's say if you have heard, let's say if me and you are talking about of any food or any restaurants, then suddenly after 5 to 10 minutes, all the content in your Instagram feed be related to those topics only. So how it is created? So while using your cell phone, you sometimes give the permission to use your mic as well to the Instagram. So all the conversation which you are having with your loved one are being heard through an Instagram app. Then those signals, so then those speeches are converted into the digital data, the binary data, and a deep learning model runs in the backend, and it suggests you that which ads or which reels or which particular profiles or which influencers you will be interested in. So this is how we are using deep learning and we are consuming this deep learning. So in the typical world, so basically we are the end consumer of these things. I hope I have answered this question.
Yeah, definitely, sir. So, Atul sir, I think this is the perfect answer, and you agree with this. Yes, sir. Go ahead.
Okay. Now let's also discuss. I think we are short of time. I have 3, 4 slides again. Okay, I'll try to be quick as much. So now let's discuss when to choose what. So I think I have just collected the guideline. That if you have a small data set, then you can use the traditional ML. If you need interpretability, then you should use the traditional ML. If you have limited sources, then you can use this traditional ML. And if the use case requires the domain expertise, then you can use the traditional ML. And for all other things like the large structured data, complex data pattern, real-time interference, the long-time accuracy, the deep learning is advanced. So, and also, this is a quite a good questions which I get from my colleagues and from my juniors, which are just out of college, and when to use what sheet. But the answer is again not that straightforward. There will be certain cases where you will use mix of them, or you will use either of this. So the data size is often the first consideration. So let's say if you have a small data set, say less than 10,000 samples, the traditional ML often perform better. Deep learning models have millions or billions of parameter and need substantial data to avoid overfitting. So let's say if you provide the small amount of data to the deep learning, so what it does, it will try to overfit the data. So I think in the traditional ML also, in the linear regression, we have this problem of overfitting and underfitting, where we use the L1 and L2 regulation technique to overcome those things. So if you feed the small amount of data to the deep learning models, then it might have the overfitting issue. But the traditional ML algorithm with their simpler architecture can extract meaningful pattern for smaller data sets. So when you use linear regression, it's just a straight line which the model tries to fit in for the scattered data sets. But let's say if you feed in more and more features, sometimes it happens that it just try to follow that line, and that would not be a correct picture for the ancient data or of the large amount of data. However, the data size is not about just quantity, it's also about the complexity. So let's say if you're working with the images, audio, video, or let's say the speech or the natural language. So the deep learning often excel even more moderate sized data sets, especially when you can use transfer learning from pre-trained models. So now in the current era, we have many pre-trained models like, let's say we have MPNet for uh, from Microsoft for vector embeddings. We have Llama models which are already pre-trained. So let's say if you are working, let's say in a HR department, now you want to create a chatbot for your all employees. So let's say in a HR department, you have, let's say, hundred of thousands of policy documents for your employees. What is the leave policy? What is the probation policy? What is the maternal leave policy? What is the advanced salary policy? And you might have hundreds and thousands of different policies. Or let's say, and when you join an organization, then HR departments give you that policy documents as well, the bunch of which has 1,000 or 2,000 pages of very overload information. So in the current era, many organizations are creating a chatbot, the internal chatbot for all these employees. So how these chatbots are created? So they don't create this transformers or the deep learning models from the scratch. What they do is they just use a pre-trained models, which is a LLM model, large language model, and by using the RAG, the retrieval augmented generation, what they do is they just try to give the context to the pre-trained models by embedding those knowledge base. So for this particular use case, the knowledge base is all the HR policies. So let's say if you embedded all these policies to a pre-trained models and the output when you make a API call. So let's say if you have trained your model for all these policies and you have created a chatbot and you will just type how many personal leaves are eligible in the current financial year. You just type this question. Then on the basis of those documents, those pre-trained model, the LLM model will answer your question in a natural language by referencing those documents. So this is how you know the pre-trained models are used quite often. So the example which is just I provided is just a very basic examples. These types of things are quite often used in the manufacturing setup as well, where you have millions of millions of pages to understand the working of very very big machines. You have a large amount of logbooks and all these things. And also in the current industry, let's say if you use a WhatsApp for the personal banking thing. So let's say if you hold a IDFC bank account and using your registered mobile number, you are just using the internet banking, you can directly see your balance or the last 5 transaction details from using WhatsApp only, and that too in a natural language. So how these are done? So these pre-trained models are sometimes linked to the databases as well. So let's say if you are having a query, then it will go to the policy knowledge base. It will go to the database and will try to reference that which is the account number. What is, by having the proper authentication mechanism, obviously, and you can have, and you receives answer in the WhatsApp chat that this is your final balance, this is your last 5 transaction details. So this is how, so in the general era and this current thing, this is all being possible using the pre-trained models only. And this has been, so this was quite a long journey from 2000, where the ML got very high popularity. Then deep learning model came, given there were the very huge data sensors developed by AWS and Azure and the Google, and we had that very high computational power, the computational capabilities where we can process the millions of data at the same time, which was not the earlier case. And that's how we have evolved from the traditional ML aspects. And the time is also a very crucial way. So there might be some projects where you will require the results in a week or a 2 week. So the traditional ML models can often be developed and validated very quickly, making them ideal for the rapid prototyping. So let's say if you want to create an MVP, the minimal viable product for any of your client or any of your business owners, then the traditional ML is quite a good thing just to start. Anyway, in the going forward, when we agree, we scope out the things, we have the discovery phase, we have a research period as well where we try different models, and we can obviously experiment the deep learning models as well. But when we have to just do a quick and dirty thing in a very short amount of time, validating the results to the business as well, then the traditional ML is quite suggested. So it makes them preferable for the POC work, the proof of concept works. But the deep learning on the other side requires more time for architecture design, hyperparameter tuning, and the training. Now, considering now there are certain cases where some of the team members will have the good exposure on the traditional ML system, like linear regression. The persons who are coming from the economics backgrounds, like let's say uh, the Delhi University MSc economics grads, or the Chennai University LSM grades, they have very good exposure on econometrics, and they are really good on uh, time series forecasting and all this linear regression stuffs. But the engineering grades, especially the computer grades, are mostly more inclined over the agentic thing, the rack thing, the deep learning things. Now it's again depends in your team that how you balance those things. So the deep learning requires programming skills, familiarity with frameworks like TensorFlow, PyTorch, and understanding of the neural network architectures, which is not quite seen in current era. It's evolving, but you will see your folks in data science who are mostly well versed in ML, and those will be around 70 to 80% of the candidate. So in the practice, the best approach is often hybrid, which was the answer by most of you as well. So we use traditional ML for quick baseline and interpretable components, and then explore deep learning for complex pattern where we have sufficient data. So there is also some cases where the data gets involving. So let's say if a company has launched a new product, let's say now how this product is performing in the real world, in the market, so you have to wait for at least 6 or 7 months to have a good amount of data. But let's say after a month or 2 months, you have to do a quick data thing to suggest a business for a new strategy. Boss, you should do these things for this new product because the data is showing like this. Then you will use the traditional ML model. But let's say if you want to build a longer strategy, like after 2 years down the line, 3 years down the line, then you will experiment the deep learning things as well. I think we are over the time. So I'll just take 5 more minutes. Is that okay, Mr. Manoj?
Yes, sir. Yes, sir. Sure. You can continue.
Yeah. So now let me just share real world success stories. I think that was a question from Mr. Santosh as well, that how we are using. So I'll just give a just quick background regarding this. So now let me share some compelling example of how both traditional ML and deep learning are transforming industries, which can help illustrate, this concept to us. So in the healthcare, we can both approach working. So we see both approaches working together. So the traditional ML algorithm analyze the structured patient data like lab results, vital signs, medical histories. Now, and to predict the treatment outcomes. So let's say uh, if a patient is getting admitted to a hospital for a longer time, 15 days, 20 days, so there are some models being generated where, you collect the blood test results for each day for that patients, to predict that would be treatment outcome, whether the patient will be okay or it will have some alignment or not. While the deep learning are very useful in the medical imaging, like detecting cancer in the X-rays and MRIs with accuracy that often exits human radiologists. So there are some cases where, the diagnosis by deep learning models have surpassed the radiologist diagnosis in the terms of accuracy because they use the deep learning things as well. But it's not that we can directly trust uh, the deep learning model outcome for this sensitive things, the predicting, the diagnosing the MRI. Anyway, the doctor's opinion is required at the end. But there are some cases, and there is a good amount of research going on these factors as well. Also, in the current era, we use this Fitband and the Apple watches, which try to predict that, your heart, how's your heart health, how's your body health, So these are mix of, the traditional ML and the deep learning models as well. Sometimes your model also, your smartwatch also gives, also detect the air quality index in the where you are. So let's say if you are going to a smoking room, let's say if you're going to a bar, then your smartwatch also will directly tell you the AQ is not good, please get out if you want to have a good heart health sort of things. If I talk about the automotive industry, now it has again have a the hybrid approach. Yeah. So the traditional ML handles the structured sensor data for the engine optimization and the predictive maintenance. So this predictive maintenance is a very good thing, which is currently going in the airline and the manufacturing setup. Very, very good amount of projects and very high investment on this predictive maintenance things. Because there are certain instances where, if you have the scheduled maintenance for your machines as well, but there are certain cases where you have the unexpected maintenance. And those unexpected maintenance caused heavily to the industry because uh, downtime, there is a downtime, the equipment get closed, there is a impact on the supply chain as well. So this deep learning powers the computer vision systems that enables the autonomous vehicles to recognize the pedestrians, the traffic signal as well. So in the current era, you will see a lot of examples using the automated car. So how this automated car is working on, how the automated car knows where to stop, where to take a turn, where to uh, stop, and how to follow the traffic rules. So there are deep learning models. So I think in a period of seconds, millions of images are snatched through the camera and that are get processes and that get processed and tells the automatic car, where to stop, how to pass an obstacle, all these things. And for the financial services, we use traditional ML for credit scoring, risk assessment, and all these things. So I have extensively worked on this, the credit risk assessment part of it. So let's say if we are going to, so let's say if you're HDFC Bank and you take money from your customers and at 6% or a 4.5 interest rate, which we get in the saving interest, and that money you give as a loan to other customers in the form of personal loan or housing loan at a higher interest rate, and that difference is the income to the bank. Now every regulatory body has a requirement to have certain economic capital reserved in the bank. So in the case, let's say, consider a case where all your personal loan customer or a housing loan customer have defaulted. They are not able to pay back their money. But that money is not yours. That money belongs to all your deposit customers which have booked a fund deposit or have money or saving account. So you, as a regulatory requirement, you must keep certain amounts of funds reserved for that particular scenario. So in that particular scenario, you do a modeling like the probability of default for all your customer base. You build a logistic regression model where you calculate the probability of default for all your loan portfolio, your lending products. You build a expected credit loss model, the ECL models, and you finally arrive at this one. So this traditional ML have a quite good usage in the credit scoring and the reporting side. And simultaneously, the deep learning detects the sophisticated fraud patterns and enables algorithmic trading, system trading. So a very good example of deep learning in the financial sector is the automatic trading, which we have. So when you create an automatic bot for doing the trading system, so let's say if you are in a forex trading where you just do the trading for USD to INR or let's say ISD to JPX only. So now there arrives a millions of different parameters. So if you feed to this deep learning model, then just take a stock of it. So in the manufacturing setup, the traditional ML optimizes the production schedules and control processes. And the deep learning analyze the images from the production line, which we already discussed. And there are good use cases in the cybersecurity, education, retail, agriculture, and research as well, which can be easily found on. Yeah. I think let's just spend 2 more minutes. I think I only have 2 more slides. So again, this is again a slide which I've prepared to just help you guys. If you have roadblocks, then what is the solution? So like if you have the resource limitation, then you use the cloud solution and academic partnership. So what I mean by academic partnership, so many of the industries like this, the data centers have a good offers for having an academic partnership with the colleges. So they provide free Azure, AWS accounts, to the students to have those hands-on and the good computational type, the techniques as well. So, and what are the future trends and opportunity? So I think we are in the era where we already revolutionized the AI. So from the last 3 years, the demands for AI engineers have significantly increased, and I highly encourage all of you to upskill on that aspect. Whether if you are in the industry, if you are in the academy, so if you have that knowledge, then you will have a good position in the market, would I say? And so the next coming things are the auto ML, edge computing, explainable AI for the black box as well, the quantum ML, the neuroformic computer like brain like processing, and all these types of research is going in the Meta and the OpenAI platforms. So having said that, I think this was my last slide. If any of you have any questions, any concerns, please let me know. Thank you.
So one simple question is there, can we use deep learning in stock market prediction?
Yep, you can definitely use. So there are certain apps like compounding.ai, and compounding.ai and Fever and many more, which use deep learning to tell you for which stock you should go and not.
Sir, one question from my side. What are the most effective tools for data augmentation?
Can you please elaborate, Manojji, what you mean by
What are the most effective tools for data augmentation?
So when you say data augmentation, can you give me more context?
Means when we have not sufficient data, we can take help of data augmentation to produce
Okay,
specific.
got it.
Yeah.
So in that context, so if you're lacking the data, so
Yeah.
so it again depends on the business case, Manojji. So
Yeah.
let's say if you are working on a financial services use case to have a to predict a credit score assessment score, on for which credit score you will give a loan or not, And let's say if you're a new bank, you don't have that amount of data for your customers which are coming. So there are external data as well, which are marks. Those are not personal sensitive, the which are not PII data, but you can leverage those data for your purpose as well. So there are different firms working in this third party data things. So there are some GDPR acts for that, for those types of things. The personal data is not shared, but the transactional data and the behavioral data, you can use those data.
Okay.
Yeah.
Thank you.
Yeah.
Rashmi madam, over to you.
Thank you, sir. I hope I'm audible.
Yes,
Yeah,
yes, yes.
audible.
Thank you, sir, for your profound and insightful session. I'm sure it will help our participants grow better. And thank you, sir, for connecting with us, sir.
No worries, no worries. No.
Madhu sir, just
We did that.
1 minute. I'm taking one snapshot of your.
Okay.
Yeah, thank you. Madhu sir, we are highly grateful for your time and insights. And despite of your busy schedule, you have spared time for us. So a big thank you from CDGI Group.
No worries, no
From
worries.
my side.
Yeah. I mobilize. Thank you so much.
Yeah.
Thank you. Thank you, sir.
Thank you. Yeah. Bye bye.
Thank you so much.
Okay.
Sir, shall we start with the second session?
I think sir has joined or not?
Sir, I'll just check.
Sumit sir has joined or not?
सर ने ज्वाइन नहीं किया है।
He's joining. I think joined. He has joined, Sumit sir.
ठीक है सर, मैं कर
उनका सर का नाम दिख रहा है कि नहीं दिख रहा है सर आपको?
मेरे को नहीं दिख रहा है।
ओके। हेलो। जी सर। जी सर। सर आपने, हाँ हाँ सर, किस नाम आपका सर? एक्चुअली नाम पूरी पार्टिसिपेंट लिस्ट में दिख नहीं रहा है सर। आपने किस नाम से, मतलब सर आपने, मतलब आपके जूम, अच्छा, पर सर आपने किस नाम से ज्वाइन किया है वो बता दे तो हमको दो एक मिनट लगेगा सर उसको। सर आपका मतलब क्या नाम आपने जूम में, मतलब क्या नाम डाला हुआ है सर? तो आपका खुद का फुल नेम ही डाला हुआ है कि कुछ नहीं, लिंक तो ठीक है, पर सर आपके जूम में वो पूछता है कि आप किस नाम से ज्वाइन करना चाहते हैं, तो वो ना, हाँ दोबारा फिट करके एक बार ज्वाइन करिए सर प्लीज। तो सुमित सर, सुमित सर, सुमित सर, हेलो।
यस सर।
अभी आप वो कर दीजिए सर कि पार्टिसिपेंट को पूछना पड़े ज्वाइन करने से पहले, तो मालूम पड़ जाएगा आपने को। तो एडमिट हो गया तो मालूम पड़ जाएगा।
ठीक है।
उसी मोड में ले जाइए जब वो एडमिट करने का ऑप्शन आता है। कर दिया?
यस।
हाँ, अभी अब किसी को मत करना सर, अब वेट करते हैं अपन।
सर एडमिनिस्ट्रेटर से ज्वाइन करा है क्या?
सर पूछ रहा हूँ मैं, रुको सर, क्योंकि सर एडमिनिस्ट्रेटर पिछले 4 दिन से इस नाम से कोई ज्वाइन कर रहा है ऑलरेडी सर।
एडमिन नाम से ज्वाइन कर रहा है, एडमिनिस्ट्रेटर से
अच्छा।
नहीं।
सर एडमिट करिए, पूछ लेते हैं अपन। एडमिनिस्ट्रेटर को आप एडमिट करिए सर, पूछते हैं अपन।
एडमिनिस्ट्रेटर को हो राइट देती है, एक बार आप
हेलो
देख लीजिए, अगर सर है तो फिर वरना हटा दो।
हेलो
सर हैव यू ज्वाइन?
मनोज सर, कैन यू लिसन मी?
यस यस सर, लिसन, आई कैन लिसन यू सर।
माय वॉइस इज ऑडिबल?
या सर, परफेक्टली ऑडिबल सर।
ओके।
थैंक यू फॉर ज्वाइनिंग सर। सर जस्ट 1 minute, give me 1 minute sir to just take your snapshot. Yeah, thank you sir. Yeah.
Yes. So we can start.
Yes ma'am, yes.
For the next technical session, we have with us Dr. Ugrasen Suman sir. He's a professor and head at the School of Computer Science and Information Technology, Devi Ahalya University, Indore. He holds a PhD in computer science and a master in computer applications from Rani Durgavati University, Jabalpur. With over 23 years of teaching and research experience, his expertise lies in software engineering, software architecture, and big data software engineering. Dr. Suman has authored 4 books, published over 125 research papers, and supervised numerous PhD, MTech, and postgraduate research projects. He has held key academic administrative roles, including Dean of Engineering Sciences and Chairman of the Board of Studies. He is actively involved in curriculum design, academic inspections like UGC, NAC, NBA, AICT, and has served as an expert in various selection committees, including IITs and public commissions. A member of IEEE, CSI, IACSIT, and IAENG, Dr. Suman is also a reviewer of leading journals such as IEEE Transactions on Software Engineering and Willy Journal of Software Evolution and Process. He continues to contribute to the advancement and computer science education and research in India. It's a pleasure to have you among us, sir, today. I would like to request sir for the next technical session. Sir, please.
Okay, thank you, madam. So, good evening to all participants.
Good evening sir.
First of all, I would like to thank Chamili Devi Group of Institutions for uh, inviting me to share my experiences in ATAL FDP sponsored by AICT. As you heard about my profile, actually I am working in the area of software engineering, but my latest research work is going on in the area of AI based software development, specifically deep learning and agile, which is being used in software development. So the title of today's my presentation is Deep Learning Models in Secure IoT Environment. It's a very common topic, IoT environment. All of us in computer science know what IoT is. Now I'd like to share the presentation. Sir, my slides are
Yes, sir,
visible?
visible, sir, visible.
Okay.
Yeah.
So my topic of presentation is deep learning models for secure IoT environments. In this session, I will be talking about little bit about IoT environment, that we know how IoT is useful in designing various type of systems. But when we interact with the IoT devices while designing any system, so being a human, it is very important to safe and secure ourselves, our data, our environment with the people who are connected with the IoT environment. And another aspect is which is moving around us in computer science, that is artificial intelligence. So under artificial intelligence, there are various machine learning mechanisms which helps us in the development of this type of applications, and one of them is IoT applications. So under machine learning, we have an approach called deep learning. It is one of the specialized domain of machine learning. So in this presentation, I will be talking about the different aspects of deep learning and deep learning models, and the things which can help us to design or work out with the secure IoT environment. So this is all about the content of my presentation. That
Sir,
is
sir, I think your slides are not moving because we are.
yeah, slides are not moving. So
Yeah.
my presentation is deep learning models for secure IoT
Yeah, so
environment.
title slide is visible, but the content slide you just mentioned not visible.
Yes, it is not moving. I'll
Okay, sir, fine.
slide it. Okay.
Yeah.
So as you heard in my biodata, I'm working in Devi Ahila University, Indore. It is a state government university in the Department of Computer Science and Information Technology. And most of, as I told you, most of my work is now related to machine learning ideas, specifically deep learning, along with the agile software development in designing various kind of applications. So this is the content of my presentation. First, will be talking about IoT and its basic fundamentals and various aspects of IoT. Then various key characteristics in IoT. Then what are the security challenges in IoT when we design any IoT application? Then I will be discussing about the deep learning, which is part of machine learning under the artificial intelligence. Then what are the various deep learning models? Then how deep learning can help us in designing secure IoT environment. And at the same time, I will be discussing on deep learning applications and the challenges which we face in designing the IoT applications. I think participant mostly are in computer science background. They know what IoT is. IoT is basically a vast ecosystem of interconnected physical devices embedded with sensors, software, and network connectivity that collect and exchange various type of data. So it is a new era, Internet of Things, where we can connect various physical devices along with the some sensing mechanisms, means some sensing devices and some softwares which help us to sense the data And if we connect any physical device with any kind of software, definitely we need some network connectivity of good bandwidth. So IoT is basically interconnected environment of physical devices, which is comprised of sensors, software, and network bandwidths. So when we talk about IoT, it enables us to connect physical objects to send and receive data over the internet without human intervention. Generally, in earlier days of application development, we provide certain input, then accordingly processing was performed to find out certain results. But in case of IoT applications, there is minimal interaction of human or any physical input in IoT applications. So it is observed that IoT impacts various sectors in real life that we are observing in our day-to-day interactions in various domains. You are also aware of all those things like smart homes. We use thermostat, smart lights, security cameras, and so many things are there. Similarly, wearables like fitness tracker, smart watches, and so many things are there. There are various IoT, industrial IoTs like robot packages, robotic softwares used in different kind of domains like medical, education, and handheld devices. Smart cities for traffic monitoring, waste management. We use IoT in agriculture also for farmers that they use to speed up the interconnectivity and monitoring mechanisms in their crops as well as soil. In transport also, we use various kind of IoT devices for monitoring and tracking the transport vehicles. So there are so many applications. Now, software companies are moving to design automated mechanisms in almost every domain so that minimal interaction, minimal interference, human being is being utilized. So in order to speed up the performance of various applications, IoT has become nowadays very useful kind of device in different domains. So what is important thing in IoT applications? So there are various characteristics when you will Google on browsers, you will find various characteristics of IoT, but the most important characteristics means key characteristics in any IoT application is sensing mechanism, communication, and actuation. Sensing mechanisms basically are the devices, are the parts which help us to gather data from the environment. As I told you, human intervention, human interaction is very less in IoT applications. So some sensing mechanism is required to gather data from the environment. So here we use various category of sensors, means physical devices to sense the data, to gather the data from the environment as and when the situation arises to gather the data according to the different kind of situations. So we use here sensors for sensing the data, and we use various type of sensors depending upon the domain, like temperature sensors, motion sensors, pressure sensors, light sensors, humidity sensors, image sensors. So there are various category of sensors, and the use of sensor depend upon the type of application which you want to develop, right? If you want to deal with the image data, then you will use image sensors. If you want to deal with the weather data, you can use humidity sensor. If you want to deal with the electricity, then you may use light sensors. Similarly, sensors may be used as and when you have category of data that will help you to sense and react accordingly. Then the second important characteristic is communication. If you want to connect the physical devices from where the data is coming from different sources, so we need to provide certain kind of internet, right? So network is very important part in IoT applications. So various devices may be connected with the help of Wi-Fi, Zigbee, and various type of plans, Bluetooth, or you may use any other kind of, internet connectivities, and you are aware of all those things. Wi-Fi, it is available, it is remotely available internet facility. Zigbee is basically wireless communication that is specifically used for IoT applications. Bluetooth, so these characteristics mean to provide a kind of internet bandwidth so that physical devices can be connected to provide means sense the data. And the third important part is actuation. Actuation, it is basically a process that help us to react according to the sense data which we have read through sensors. So there are various type of actuators, means the devices that can act upon the data which we have received through sensors. For example, if we have received electrical signals, then we can say turn on light, switch on, switch off. So here we can use electrical actuator. Means actuation is basically a process that help us to react according to the data which we have received from sensors. So there are various kind of actuators, like if we deal with mechanical, then motors are used, then solenoids are used. If we deal with water, hydraulics are used. If we deal with the electric, then LEDs are used. So there are so many category of actuators that will react according to the data which we have sensed through various sensors. So these are the three key characteristics in IoT. Sensing means with the help of sensors, communication with the help of internet mechanisms, then actuation with the help of various kind of actuators. So when you will refer books, you will find various type of actuators, sensors, and internet mechanisms in the form of characteristics of IoT, right? So when we implement IoT applications, when we develop the IoT applications in real life in different domains, we face various kind of issues. So some of the common issues which are readily available on various sources, and these are listed in my presentation also. Security issues, that is various kind of malfunctioning may be noticed while interacting with the physical devices because we are not there and it is remotely available. So authentication mechanisms and other firmware mechanisms and interconnection between devices are on the target of the cyber technocrats, which may breach the data and may have different kind of malpractices. And some of the common security vulnerabilities you might have heard about: botnet, DDoS, and so many things are there. So botnet basically when we connect various devices through internetwork, means internet, so there may be malfunctioning in between devices to steal the data, to hack the data, to disturb the data, to add some unused ideas, unused information inside the data and information. Similarly, DDoS attacks, denial of service attacks, these are distributed kind of attacks if we are connected with the internet. So, but obvious it is very vulnerable because internet is moving through various kind of PCs, servers, IoT sensors, and other devices. So security is one of the important aspect. You can say it is issue in designing the IoT application. Second thing is privacy concern, because sensors are reading data and it is huge in nature, means huge amount of data is collected through sensors and there is no control of user as sensors are independent. So when we share our data through sensors and sensors are connected with other devices with the help of internet, so privacy is a major another major concern. How can we make our data private so that others cannot leak or disturb it? Third is interoperability issues, because IoT has interconnectivity with different kind of devices and each device may have different kind of protocols, means the way of communication. So there is no standard practice, there is no standard protocol across the manufacturing industry or manufacturing applications. So there may be mismatch of interoperability issue. So sometimes developers and users both face this issue, interoperability among devices. Then scalability is also a very important issue, because managing a large number of heterogeneous devices, so there may be an issue of congestion control, network congestion. So if we increase the number of devices in IoT application, so performance may decrease at any time. So it is observed in many research works. Then power and resource constraints, because sensors are isolated devices. There is no direct interference of electricity in remote areas. So we have to feed some kind of battery backup. But battery backup has limited life. So limited battery life for sensors and low processing power and memory means it will consume a lot of energy. So this is also very important issue. Then managing the device is also an issue, because you are sitting at your home, you want to manage your office. You are sitting at your home, you want to coordinate each and every corner of your home. You are driving the car and you are connected with various kind of your uh, home applications. So it is sometimes very complex to manage, means configure remote devices and monitor them. And in case if any problem occurs, then troubleshooting becomes very challenging issue. Then we have to deal with physical devices. We have to go there. We have to see what is the actual problem. So these are the some common issues while implementing the uh, IoT application in real life, that we have seen in our daily life and in various research papers. These are very common issues which we have observed in designing and development of IoT applications. So anyway, we have to develop the IoT applications as it is a need of today's smart life. So what kind of various security challenges in IoT as per the issues which we have raised in previous slide? So some common security challenges are listed here, like common threats, like as I told you, botnet attacks, botnet threats, data breaches may happen. Means unauthorized users may access your sensitive data, which is very critical concern. Then DDoS attacks, means because your device is connected with the various devices with the help of heterogeneous distributed environment. So data may be stolen at any place, and it may be mass disruption. That means if you disturb a data at a particular place, it will disturb the activities connected with all devices. Similarly, malware attacks, some malicious code may be inserted. Spoofing attacks, some untrusted parties may be intentionally leak your data. Similarly, another security challenge is device limitation, because each of the devices which are connected with IoT have low processing power and memory, because we have certain limitation in fixing the processing power inside IoT device, because it is limited in capacity. And same thing, memory also, we cannot store much memory, we cannot have fixed much memory in IoT applications. Similarly, I told you battery life, it is very limited, so it is very cautious. And one very important thing is firmware. It is very difficult to design a device, but the this will become more difficult if we do not update any firmware device which is designed for a specific application. For example, if we have designed any smart meter, and if the smart meter is not updated regularly, then it will be obsolete, and the people will face various kind of problems in the upcoming years, and then it will become very obsolete, and this legacy system may need tremendous maintenance thereafter. So maintaining and updating the firmware part is also very difficult issue, because it is designed only once and used in various applications. Similarly, heterogeneous environment, as I told you, there are various kind of manufacturing mismatches, different kind of protocols are used, so there is no uniform standard for all protocols. Also interoperability and integration issues. Then a very interesting thing which is observed in various research paper is the awareness of users. Nowadays, designing an application, IoT application or other application is very common and easy job. But giving a proper training to the user for using the IoT application and managing it in the domain for which it is basically designed. So very common things which are observed in IoT application is password mechanism. For you can see here poor password practices. Whenever any update comes to set any password in IoT application, generally people set very common passwords. So it is vulnerable to breach. Vulnerable. Anybody can crack the password. So some complex kind of passwords and other user awareness training must be given for operating the IoT applications. And some privacy settings, like which part can be accessed by administrator, which part can be accessed by user, which part can be accessed by the administrator, which part can be accessed by specific government agencies. It has some privacy settings, so that we may have layers of privacy mechanisms, and we can then minimize the risk of any kind of security aspects. Then the need for intelligent defense. See, there are mechanisms which exist in safeguarding, in protecting the IoT applications. So traditional, that means static rule-based systems are ineffective against evolving threats. Now, technocrats are becoming very smart, and they have a number of ideas to crack the applications, to steal the data, to breach the things. So static rule-based mechanisms will not work most effectively in today's smart hackers. So static rule-based systems are basically the systems in which rules are set according to what we require. Generally, we set programming and we write if then else. If this condition is true, then we have to perform this. So this kind of mechanism works well if we have very limited, kind of actions, and systems are not smart, where machine learning mechanisms are not used. So for traditional systems, static rule-based defense mechanisms are okay. But when we deal with today's smart IoT-based applications, where we have no intervention of human activity, then we need certain kind of logical kind of ideas, so that without intervention, machine can automatically learn the things, predict the things, and tell you what is the problem, what kind of troubleshooting is required.
Sir, sorry to bother, interrupt you. There is one question in the chat box. May I ask?
Yes, sir.
Yeah. The question is it correct to use LoRaWAN to control actuators that required immediate response to sensor input?
Is it correct to use LoRaWAN
LoRaWAN
to control actuators that require immediate response to sensor
input?
Yeah.
Yeah.
Sometimes we can use it, but it has various other, impacts also. but sometimes it is used. Yes. So I was talking about the static rule-based systems. It is fine in case of traditional systems, but in smart IoT applications, some deep learning mechanisms are required, deep learning models are required, so that the things can automatically be learned, adopt and detect advanced threats in real time. And this happens because there is no intervention of human being in IoT applications. So deep learning mechanisms works well nowadays in designing the IoT applications. So let us understand what's deep learning. And it is very common topic nowadays, and most of us know what's the deep learning. So as this diagram tells that in early days of intelligent computing, we have artificial intelligence, and in this artificial intelligence, we had various kind of mechanisms for performing the decision making capabilities in our systems, just like human brain. And we had designed various kind of applications which is capable of reasoning, perceptions and decision making. So in early days of intelligent computing, that is AI, is basically mechanism which had the capability of reasoning, perceptions and decision making. And there are various applications of AI which is being used for the last many years specifically in medical field, means healthcare sectors. Dental and machines are very common expert systems which are being used as an AI systems. Then chat is used, then virtual assistants are there. So there are so many applications of AI. So with the advancement of AI, some new kind of mechanism came into the picture with the advancement of large amount of data, that is machine learning. It is basically means it machine learning focuses on various kind of algorithms that identify patterns in data to make predictions or decisions when new data is input. Intelligence is the same, but here we deal with huge amount of data, and that rule based mechanism might be used in AI, but here we take decisions by training the machine with the help of data, means the machine learns from data. So without using a complex set of different rules, this approach works very well. For example, you can say recommendation systems. We generally use various web services to find out any item. So based on our search request, machine automatically provides you certain results. So based on previous experiences, previous results, previous data, machine provides you. So for this purpose, we use various kind of machine learning algorithms in artificial intelligence to learn the machine with the help of existing data. So with the advancement in machine learning, and the specialized areas in machine learning like image processing, natural language processing, and various other specialized areas came into the picture. So it had become compulsory to design new mechanisms for specialized areas. So deep learning came into the picture. It is basically a technique to perform machine learning inspired by our brain's own network of neurons. So it is basically a specialized machine learning technique that uses artificial neural networks, different kind of neurons with multiple layers of learning. So there are various kind of filtration. We start with the basic data, means abstraction, then moving towards filtering the data to extract some meaningful. Then again we provide certain again kind of filtration. So there are various applications are being used nowadays in deep learning, like speech recognition, image recognition, natural language processing. Object detection is a very common application which is being used by researchers for detecting the objects in designing the complex applications. So deep learning is basically a specialized domain of machine learning, and machine learning is a part of artificial intelligence. So in early days of designing the intelligent applications, we were using artificial intelligence, but later on, as and when data has become huge in nature, means for massive data, we started using machine learning. Then under machine learning, we have some specialized areas like image, object detection, and all those things. Then we started using deep learning. So deep learning is a part of machine learning, and machine learning is a part of artificial intelligence. So deep learning is a subset of machine learning based on artificial neural networks with multiple layers designed to automatically learn and extract complex features from large amount of data. And it may means machine learning may require sometimes manual feature extraction. If we are not satisfied with the decision making and results, then we may have intervention. But deep learning learns features strictly automatically from raw data. We need not to interfere with the any kind of data. So as I discussed, IoT applications do not have human intervention, human interactions. So in such cases, deep learning has become very intelligent and useful idea, useful technique to secure IoT applications, because if its nature that it automatically reads data, it automatically extract information from raw data. There is no need of human intervention. So the deep learning has various characteristics, but some of the common things which we uh, found in literatures, that is deep learning uses hierarchical feature learning, and this hierarchical feature learning is basically kind of uh, models that learn at multiple levels of abstraction in structured way, and it basically start with the layering of various information and understanding the data, and then building from basic to complex patterns. So that is what hierarchical feature learning. That means we start with the abstract data items and move towards filtering through layered architecture, and then finally building the things from basic to complex patterns. So our purpose is to find out the complex pattern which is existing in the huge amount of data. But this happens by applying various layers of, you know, various layers of learning. Deep learning deals with the large amount of data sets, and at the same time it consumes computational power. So we must have had all those things, and it is observed that it is excellent for pattern recognition in unstructured data. No label like image data, log data, traffic data, and all those things. But some examples which I already told you, where deep learning mechanisms have become very useful, like image recognition, natural language processing. In this uh, domain, we have, specifically in India, we may have different kind of languages which are spoken by regional people. So how the things may happen, how the things may be processed with the help of natural language processing translators. Here, deep learning may be used. Autonomous vehicles, healthcare, robotics, fraud detection, virtual assistant. So you might have seen various kind of chatbots are there. Chatbots basically learns the things based on previous data. So with the help of these ideas, which are where deep learning mechanisms are used, then literatures state that deep learning may also be used in designing the secure IoT applications. Means deep learning may be used in securing the IoT applications, IoT environment. So our purpose is to basically discuss how deep learning models can help in designing the IoT applications. So let us discuss little more about deep learning models. There are various category of deep learning models. These models are basically part of machine learning, which are readily being used in AI also in early days of computing, intelligent computing. But now these things have been little bit changed, and we call them deep learning models. So some of the deep learning models which are commonly used in designing the IoT applications, like convolutional neural networks, CNN. CNNs basically, it uses convolutional layers with filters to automatically extract features from input data, followed by pooling layers to reduce dimensionality, and then connected layers to identify objects or classify objects. So convolutional neural networks are used, it is observed to be used in image recognition, spectrograms, means grid-like data, wherever the grid-like data exists in real life, it helps us in designing such applications, that is object detection. Also, it is used for malware detection and image-based surveillance. So convolutional neural network is one of the important deep learning model. Then another type of model is RNN and LSTM, means recurrent neural networks, RNN, and LSTM, that is long short-term memory models. So whenever the sequential data is required to be processed to find out some pattern inside it, like log tables, network traffic, and many more examples you can see. In that case, we can use recurrent neural networks. Similarly, some more ideas, means more applications may be there where RNNs and LSTM are used for detecting time-based anomalies. Then autoencoders is another model. So autoencoders are basically unsupervised learning mechanisms, learning tools, you can say, which learns to compress and reconstruct data. So I think there is no need to discuss much more, but we must understand the type of learning. Generally, we see there are supervised and unsupervised learning. You might know it. Supervised learning deal with label data set. For example, classification, regression, where some conditional things are there and having certain boundaries of condition, true or false. So we can move to true side if this condition is satisfied. Otherwise, we can move to the false side. But on the other hand, there is unsupervised learning, which deal with unlabeled data with undefined output, where there is no prediction of outcome. We are processing the data, we are processing the input data, but there is no prediction of certain defined outcomes. In that case, we use unsupervised mechanisms, like clustering mechanisms may be used, association rule may be used. So it helps to find out certain patterns. So based on unsupervised learning, we have certain automatic mechanisms known as autoencoders, which use encoders and decoders. Encoders means autoencoders are the another category of deep learning models. Then FNN, feed forward neural networks, where information flows in a single direction, one direction. That is, we read input, then it moves to some hidden patterns, then we reach to the output layer. So here there is no feedback loop, like no back propagation, no supervised learning. Here supervised learnings are used for training. So FNN is another deep learning model. Then generative adversarial networks, GANs, that is some simulators are also used for generating synthetic data and training some data diversities. Then transformers are basically means transformers are the basically architectures which consist of encoders and decoders, which allow for parallel processing and faster training. And it is observed that transformers are specifically used in natural language processing. So transformers are another example of deep learning models. It is the state-of-the-art mechanism for sequence and attention-based tasks like natural language processing. And at the same time, transformers are useful for distributed IoT environments also. So these are the some deep learning models which are used in designing various kind of applications. But here I want to discuss why deep learning is used in IoT security. So these are the some regions which we will be discussing in subsequent slides also. Automated feature extraction, because in deep learning means deep learning models eliminate the need for human feature engineering by automatically learning representations from raw data. As we discussed, some sensors are used, actuators are used, network mechanisms are there, but no manual intervention, manual feature engineering is there. So automated feature extraction, this is one reason why deep learning may be used in IoT security. because IoT applications do not have human interactions. Then real-time anomaly detection, if any serious concern happens in real life. So the thing is, we have to go there and find out what are the root causes. But IoT applications are far away with your daily walking, daily living. So you may have some real-time anomaly detection. If you are not there, if you are not present to troubleshoot the things, some deep learning mechanisms may be used to troubleshoot. Some deep learning mechanisms may be used to, you know, mm, keep safe your data and things. So real-time anomaly detection is capable of identifying deviations from normal behavior in large scale, high volume data streams, such as unexpected device communication patterns, all those. Then adaptability to new attack patterns. As I told you, deep learning is basically used to find out some complex patterns which inherently exist inside any large amount of data. So deep learning models can generalize from previously seen attacks and detect new or unseen threat critical in evolving landscape IoT threats. So as it helps in finding the patterns. So deep learning models are really useful in finding out the uh, patterns of the attacks based on the previous attacks. Then complex pattern recognition. So it is helped to excel in recognizing subtle high dimensional patterns in encrypted data, behavioral logs, device signals which may indicate stealthy cyber attacks. So deep learning helps in designing the secure IoT applications by finding the complex patterns as it learns from data. Then scalability is also an issue because deep learning architectures such as CNN, RNN transformers can scale to handle input from huge number of IoT devices simultaneously, and it helps the parallel processing. So because of its scalability, deep learning may be used in IoT security. Integration with edge AI. So edge computing is another area nowadays moving around in computer science. So edge AI is something related to that. It involves running artificial intelligence algorithms and models directly on local devices rather than sending data to remote servers. So in when we implement deep learning models, various algorithms and model can be embedded inside the device rather than sending anything to the cloud or the any server or any host machine. So these kind of AI mechanisms can be integrated inside the IoT device. So that is another plus point for applying the deep learning models in designing the secure IoT applications. So how deep learning models are used in IoT security? As I told you, various deep learning models. So with the help of these models, we can design the secure IoT environment by CNN, by applying CNN algorithms that is effective in analyzing spatial data like images from surveillance system. GPS mechanism is also there. You can apply convolutional neural net CNN networks for GPS systems. It is also used in malware detection using visual representation of binaries inside the system. We have some representation of data patterns, how the signals are moving inside the devices. Then RNNs and LSTM, as I told you, it is suitable for sequential data like network traffic logs. So based on these observations, we can find out where are the vulnerable areas, vulnerable the things. Then detect temporal patterns also. indicating some abnormal behavior based on some previous data logs. Autoencoders, as I told you, it helps in detection by learning to reconstruct normal data patterns. If any mismatch happens in the reading the data patterns, so autoencoders are used in such applications also. Then high reconstruction error may indicate potential threats. If anything happens, then it is pointed out that there may be some potential potential threat may exist in that place. Then generative adversarial networks, it is basically used in simulated environment, which can be used with the help of some classifiers. Then transformers, as I told you, it uses encoders and decoders, which promotes parallel processing and faster training activities, which are being observed in natural language processing. And these are also useful in real-time IDS also, intrusion detection systems in distributed IoT networks. So by making use of all those deep learning models, some secure IoT applications can be designed. So there are various deep learning applications in IoT security, which are observed in our real life applications like IDS. So IDS is basically a cyber security tool that monitors network traffic and system activities for malicious behavior or policy violations. So there exist various automated intrusion detection systems which helps us to monitor the network traffic and system activities. And it has three important components, means three important activities: monitoring, analysis, and alerting. So various means huge amount of data are monitored with the help of various sensing devices. Then analysis is performed to find out certain patterns. If any abnormal behavior is observed, then alert is sent to the user that this is happening based on the training data. So deep learning applications are used in designing the intrusion detection systems, that is a real-time detection of unauthorized access using deep. Then botnet detection, as I told you, botnet is basically interconnected devices on network like PC, server, IoT sensors. So if any kind of attack happens in the communication and coordination of devices in IoT applications, then some signals may be raised, some issues may be raised and sent to the user that something went wrong. Then malware classification. So deep learning models are also used in malware classifications with the help of CNN and hybrid models. Then traffic analysis and filtering. So some congestion control mechanisms may be predicted with the help of autoencoders. Authentication and access controls, various biometric based deep learning models can be used for securing access to smart devices. Some biometric based other mechanisms may be implemented to authenticate the unauthorized access of any device. This secure firmware update. So after the longer operation of any IoT application, if any alarm comes that this device is not performing properly, So some sensing devices must be there to detect the malfunctioning of the device itself. Then some regular updates may be required. So deep learning models may be used here also to find out whether the IoT devices are working well or not. So there are some challenges in deep learning for IoT security, like data privacy and availability. Data privacy and ability, because in real life people want some IoT applications in their real life, because the because of the rapidity of real life with the technology and increasing amount of data in the real life. So users are sensitive in that case. How can we make our data private? Means how the privacy can be preserved, and all those data must be available at all time without any kind of interferences. So because of its sensitivity of IoT devices, so one should ensure that sensitive nature of IoT data and lack of label data set. That means data which is floating and sensed by IoT devices, it must be safe and available for the real use. Then computational constraints, because IoT devices are in operation with some battery life. So there are some resource constraints also. Processing power is there, but how much capacity of processing power can be given to the IoT devices, and how much capacity of battery life can be embedded inside the IoT devices. Sometimes it is also observed that if your IoT application is working far away from the real user, for example, specifically it is observed in agriculture sector, you can say agriculture sector, where farmers can deploy their IoT application in their uh, farmhouses to watch their crops, to watch the behavior and to watch the nature of the different kind of crops, soil and water levels. So we have to keep the battery, means larger capacity of batteries, larger capacity of processors, means transformers, and various kind of high capacity resources on edge devices which is far away from the real user. So computational constraint, as also sometimes it is observed the battery has gone and the cameras are not working, sensors are not working. So IoT applications will not work in that case. So it is a very biggest challenge how to cope up with the resource limitations on edge devices which are working far away from the real user. Then model interoperability, because deep learning decisions are basically black box in nature, because how it is working, it is all about based on your data and algorithm. Your algorithm helping you to read the nature of data, and based on that means experiences of learning, means training and learning, you are taking certain decisions. So sometimes it becomes very difficult to understand the black box deep learning decisions, whether it is really useful. But in some of the domains, some of the areas, deep learning has really given tremendous result. And we have seen like chat GPT and chatbots, various, most of the software companies are designing the chat GPT like applications as virtual assistant in real life. And even in education sectors also we are using, but it is very challenging that how it is responding, how it is interacting with the users. Then model generalization. So models trained in one environment may not work in others because nature of data varies from domain to domain. So a model which may be useful in education may not be useful in healthcare, may not be useful in agriculture. So there is no common generalized model designed for all kind of domains. So one model may be used in few domain areas, but other models may be useful in some other areas. So these are the some challenges when we deploy deep learning models in designing, means securing the IoT applications. So you may find a lot of literatures on deep learning models which are useful in designing the IoT applications and securing the IoT environment also. And the very popular is your interactive GPT is one example that can be helpful in designing the and studying the literatures. You can find out the various details on IoT environment. So in this session, I had been talked about the various kind of IoT applications with their basic concepts, then deep learning mechanisms, deep learning models, and various models which I discussed like CNN, RNN, FNN, IATO encoders, transformers, which are nowadays used in real life applications. And it is observed that deep learning models are used in IDS, anomaly detection, malware detection, and secure authentication in IoT systems. So with this means despite its potential challenges, data scarcity, model complexity, and resource constraints in IoT devices, these are some challenges. Benefits are there, but there are some challenges to implement deep learning models in real IoT applications. So various research work is going on to address these challenges related to, specifically related to energy and interoperability, specifically data energy consumption. So most of the research works are nowadays going on energy consumption, green computing, green areas. So secure IoT environments demand a collaborative approach using AI, security protocols, and edge computing nowadays. So these are the some fundamental learning experiences from my side. If you have very basic questions on the discussion, you can ask now. These are the some references which you can refer. These are good books available in the market. You can go through those things. So thank you.
Participants, you can raise your questions if any you have. Rashri madam, over to you.
Thank you, sir. Thank you for connecting with us on behalf of CDGI. I would like to express my heartfelt gratitude for connecting with us. Your profound insights will truly help our participants to form better. And thank you once again, sir, for connecting with us.
Thank you so much, sir.